Hello everyone, welcome to my channel, Coder Marco. This is the day 3 of the upcoming 100 days DLN series to build your logic building. So, in this video, we are going to solve a problem in which we are using the concept of the sliding window, and we also study a concept called exactly k is equal at most k minus at most k minus 1. So, first of all, read this question. While solving this problem, we also learn this concept. Okay. So, first of all, move on. Let's read the problem first of all. So, in this problem, we have given an integer array nums. Okay. And also given an integer k. And we want to return the number of good sub arrays. Okay. A good array is an array where the number of different integers in that array is exactly k. So a good array is an array which contain exactly k different element. So a array is good if it contain exactly k different elements. Okay. So and for example we have 1 2 3. 1 2 has three different integer 1 2 3. Okay, so and a subarray is a continuous part of an array, we also know it. So we want to return the number of good subarrays, and a good subarray is an array which contain exactly k different element. Okay, so let's take this example. 1 2 1 2 and 3. Okay, and the value of k we have is 2. So we want to choose an subarray which contain exactly two different elements. So by my eyes, I can easily see that this subarray, this subarray, or this subarray, and this subarray contain exactly two different elements. Okay, so the answer and this subarray also contain exactly two different elements because 1 and 2, we here the frequency of element doesn't matter, but we have exactly k different element. Okay, so this array also contain an exactly k different elements, and this sub array also contain, and we clearly see that this sub array also contain exactly k different element. Okay, so the our answer is 1 2 3 4 5 6 and 7, and we clearly see from here that our answer is 7. Now take one another example. We have this subarray 1 2 1 3 and 4, and the value of k is 3. So by my eyes I can say that this subarray 1 2 1 3 contain three different element, and this subarray, this sub no, yeah, and 1 2 3, this subarray, sorry, let me erase it. And this subarray also contain three different integer, or this subarray also contain three different integer. So our answer is 3, exactly three different integer. So how can we solve it? So first of all, let's take another example. So While sol while solving the example, I can teach you. Okay. Let's create an array and choose the draw line option. 1, 2, 3, 4, 5, 6, and 7. Okay. And so how can we solve this problem? So let's first of all fill this array and consider the value of k is 3. Okay. And fill this array 1, 2, 3, 1, 2, 4, 6, and again 1. Okay. So by my eyes, you can see that the first brute force approach that comes in my mind is that I will generate whole subarray, and we know that generating subarray takes time complexity of n square. Okay, and after generating in each subarray, I will count number of different integers. So this will also take an another time complexity of n. So and let me use another page. So okay. So to generate the subarray takes time complexity of n square, and to check if this subarray contain a different integer, exactly a different integer take of n time complexity. So the total time complexity of our code is of n. Now we can do this problem in this way by brute force manner. In brute force manner, we can solve this problem. And if my subarray contain the if any subarray contain the exactly k integer, then I'll increase my answer. And to determine the different integer and subarray contain, then we need a another data structure to store how many different integer we have. So we can use map or set to store the number of different integer in any subarray and check if the subarray contain exactly k different element or not. If any subarray contain exactly k different elements, then I'll increase my answer. So we also use an another space in this question of n to store number of different integer. Now let's see the constraint of the problem. The size of the subarray is 10 to the power 4, and we write a code which is taking the time complexity of n cube. So it is taking time complexity of 10 to the power 12, which is very greater than 10 to the power 8. So how can we solve this problem? So initially we, as we know that the topic of this day is sliding window. So can we solve this problem by using the concept of the sliding window? Yeah, we can solve this problem by using the concept of the sliding window. But while solving this problem using the sliding window, we also need an another concept, that is exactly k is equals to at most k minus at most k minus 1. Okay, so first of all, in the previous video, I also tell you that if how can we build our intuition that this problem is solved by which algorithm. So in previous video I also told you that if our size of an string or any array is in between 10 the power 4 to 10 the power 8, then we must try to think a solution of O of n and O of n log n. And we know that the sliding window slash two pointer and prefix sum, generally taking the time complexity of O of n, and O of n log n time complexity is generally taken by the sorting, or we also think about a solution which is also using binary search. Okay, but here in the problem we want to find out the sub array. So in most of the cases, in most of the cases of sub array question, we generally use the sliding window concept with another concept. Okay, we can also use another data structure with sliding window. So in this problem, while solving this problem, we are using two concepts. First of all, we are using the sliding window concept, and we are using this concept, plus we are using an extra data structure that is called map to store the frequency, or you have to store the different integer in any given subarray. Okay, so how can we approach this problem? So let's discuss about it. Now, take an example. Let me draw the subarray. Let me draw the array in a good way so that you can understand. 1, 2, 3, 4, 5, 6, 0. Okay. 0, 1, 2, 3, 4, 5, and 6. Now consider the value of k is equals to k is equals to 2. Okay. So now fill this array. 1, 2, 3, 4, 4. Then write 1 and again 2. So in sliding window, we know that we have an starting pointer and we have an ending pointer. Initially, they are point to the 0th index of the array, and we update our end pointer in every we update our end pointer again and again, and we update our start pointer if our condition get fail. If our condition fail. Okay. So now take that case. So initially we have start here and end here, and we also using a map data structure. to store the count of different integer, how many times it comes. So now we are here and we check that we have one, so I'll increase the count of one. Then I'll check that is it my map size greater than k. So it's a my map size is not greater than k. So this is my condition which must be must be valid. If it got if this condition not get well, if this condition fail, then I'll update my start. Okay. Then I see that this is not contain the so yeah. So map size is not greater than one. So I am not updating my start. Then I move here. Then while moving here, I also update my answer because while doing this task, I want the I tell you that what I am doing here. Give me some time so I can erase all the thing. I'm taking so much extra space here. Okay. What I want to do, what I do here is that I found all sub array in which the count of different integer is less than k. So I'll count the all sub arrays in which the count of different integer is less than k. Okay. So and then to find the number of sub arrays which contain exactly k different integer, we can find by using the concept of at most k minus at most k minus 1. Okay. So I will show you the code, and while showing the code I will tell you in which step, in which at which instruction, at which step I can what I what I do. Okay. So let me show you code. So this is the solution of this problem. So first of all, I discuss the time complexity and the space complexity of this code with you. The time complexity, this solution taking is off, and the space complexity, the solution is taking off and also. And our solution is start from here. So this solution, so this return the number of subarray which contain exactly k elements. Okay. And this solve function which is I am writing above return you number of sub array which contain at most k different integer, and this solve function nums k minus 1 return number of sub array which contain k minus 1 different element. And if we know that the number total number of sub array which contain k at most k element, and if we subtract the total number of sub array of k minus 1 element, then we can get the exactly k sub array exactly sub array which contain k elements. Okay, so give me some time so I can erase it from here. Okay, that's cool. That's cool. Okay, done. Done, 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 done. Now come here again. So this is a function which I create. In this function, we have, let's call the I is equals to start pointer of our sliding window, and call the j is the end pointer of sliding window. And I'll also create an unordered map to store the frequency of each element in the given subarray. And this line will give you the size of the array, and this will store the result. Okay, so this is the standard template of our subarray. If j is less than n, we are doing sliding window. MPP of nums of j plus plus. If map dot size is greater than k, if let's call that the 1 2 3, we are at this index, we update our map, then our j is at this index, I again update our map. And if we are at this index, and let's assume the value of k is 2, so at this index I again update my j and check that if my map dot size is greater than k or not. If I am not, no, okay. And what I'm do here is that I'll calculate the total number of subarray. Initially, our result is 0. Okay. Then after that, our result is equals to j minus, initially our j is 0 and I is 0. So initially we have only subarray which contain element less than 2, which contain different integer less than 2. Then I am, if my j is here, then we have two subarrays which contain element, which contain subarray, so if I am at here, then we have two subarrays which contain different integer less than 2. So this is an subarray and this is an subarray, so I'll add my answer to this. Then at this index I'll see that this, at this condition, my condition got failed, so I'll update my start. So my start is now at this index, and is, and here the start is represented by the I. So again I'll update my answer. So in the answer we have start is 1 and j is 2, so 2 minus 1 plus 1, this will give me two subarrays which contain the two subarrays which contain element less than or equal to 2. Okay, so this is one subarray and this is again subarray. So in this way we can calculate the total number of subarrays which contain element less than, which contain different integer less than or equal to k, and we return our answer. Okay, so in this way we can solve this problem. So here we are using this concept. If you want to find the number of sub arrays which contain exactly k different integer, then we use this concept. And this concept is used in so many problem, and this concept is depend on problem to problem. So in the next video, I will bring you 5 to 6 problem on sliding window which cover all these concept of like at exactly k, at least k, maximum consecutive ones, and maximum sums of subarray, like this type of problem I'll show you in the next video. So for today, so in this video, so in the next video I will bring this type of 5 problem for you. So that's all for today, and thank you everyone for watching my video.